Good morning. For the unit, if you remember, we've been talking about smog and specifically combustion that goes to um, create some of that smog. And we looked at a case study of smog in LA and in the LA basin. So I have an image here of a combustion engine. We see the inside where the actual combustion in your car engine is taking place, and it has several steps here, and you can see that step one, this intake, we have some particles going in. Now the particles going in are your fuels. um, in your car engine, you're going to use octane as the primary fuel source, but octane is not the only thing in there. We also, for combustion, are going to need oxygen. And you can see up above here we have the formula for combustion with octane, where C8H18 is the octane and O2 is the oxygen. So those two are going to combine, um, and they're going to be the reactants in our combustion. It's what we start with. So we go to the next step of this engine, and we see that the fuel, the octane, and the oxygen are in the cylinder. They get compressed, so the molecules get pushed closer together. We get a spark from the spark plug that ignites that fuel. So the oxygen and the octane combust after the ignition, after the spark from the spark plug. And that's our reaction, right? That's the reaction taking place. Out of that, we get a couple of waste products. We get CO2, carbon dioxide, and we also get water. What is not here, though, if you remember, and we've talked about this before, but another waste product is energy. We get a huge amount of energy released. And we're getting energy released because this is an exothermic reaction. Okay, so exothermic. Exothermic is a reaction that gives off energy or gives off heat. The opposite of that would be an endothermic reaction. Endothermic reactions actually take heat in. So if you had an endothermic reaction in a test tube, the test tube actually gets cold to the touch because it's pulling energy in. So anyways, exothermic, energy is released during combustion. Everyone knows that the engine of the car gets really hot, and that's because of this explosive combustion reaction that's taking place inside and all this energy that's being released from the fuel. It's actually being released from the bonds of the fuel. Let's see, what else? I think the previous video, we talked about how energy is transferred from one media to another. And the energy transfers that we talked about were, there's three of them that we had mentioned. There was conduction, convection, and radiation. Now, we can really take a look at two of these as far as energy transfer, energy moving from one thing to another in the car engine. Okay, so first one, we get this explosive reaction, we get this hot gas and energy being released. And at first you're going to get convection. So the hot gases are going to transfer some of that energy, some of that heat into the metal of the car. Okay, so through convection, we get a transfer into the metal, gas to metal, right? Conduction, once the metal is heated, so once the cylinders around here are hot, they can transfer energy from one piece of metal to another piece of metal. And that's conduction, when it's conducted from one piece of metal to another piece of metal. And that's conduction. We don't have a good example of radiation here, um, uh, but the car engine is a very good example of conduction and convection.